Page 3 on the Unit 1 test. Now we are analyzing some graphs and then of two unknown substances A and B, and they're asking us questions about what would happen if we put some of that into a balance. Find the slope of the line for both A and B. Very similar to what we just did on the first page. There's substance A, there's substance B. They both pass through the origin of 0, 0, so all we have to do is pick the most convenient point. For A, it looks like it's this one. It crossed on the lines. I can pick any other one, but I'm just going to pick the most convenient. I could pick here and say it's 55 and 35, but why not just pick the easiest one to be able to be sure of? This is exactly on 80 and 50. 80 grams divided by 50 milliliters equals 1.6 grams per milliliter. With B, find a convenient one. The most convenient one, let me look. I would probably go with this one, at least on this board. It either looks like 20 or 21 over 40. I'm going to say that that's 20 over 40. I'm okay with that. 20 grams over 40 milliliters equals 0.5 grams per milliliter. Those are slopes, but they are also densities. It says to state the physical meaning. So how would I say this? I can say this two different ways. For A, I will use the words for every, and I'm going to just say this out loud. For every 1.6 grams, there's 1 milliliter of substance A. Or I could say for every 1 milliliter of substance A, it would have a mass of 1.6 grams. For letter B, for every 1 milliliter, it will have a mass of half a gram. Or for every half a gram, it'll have a mass of 1 milliliter. Like I was rewriting these, 0.5 grams per every 1 milliliter, or 1 milliliter per every 0.5 grams. Both of them are true. One of them is written as a density, that one, grams per milliliter, but they're both proper ways of looking at it. Next ones. What if you put 30 milliliters of substance A in one balance? What mass of B would you need in the other pan to make it balance? Well, 30 milliliters of A. I find 30 milliliters. I go up until I hit the A and I ask myself, what would the mass of that be? If that would be, it looks like about a 48 would be there. So I don't care if we're asking about substance B, gold, water, anything. What's the mass of that has to go in the other pan? If A has a 48 grams, based on my reading the graph over here, then you're going to need 48 grams. Doesn't matter what substance, 48 grams of that substance. So the reasoning, like I explained, because 30 milliliters of A has a mass of 48 grams, it will take 48 grams to balance it. The next one asks you to go a little bit further. What if you put 40 milliliters of B? What volume of A would I have to put in the pan to make it balance? So the first thing is to figure out, well, what's the mass of 30 milliliters? I got to make sure I'm doing the right one. What's the mass of 40 milliliters of B? So I go 40 milliliters, go up till it hits the B line, ask myself, what's the mass? It's going to be 20 grams of B. So I need 20 grams of A. But the question isn't how many grams of A, what volume of A. So I need to figure out, if I had 20 grams of A, that's A, it meets the substance A line, what would its volume be? I'm thinking about 12, maybe 11, so it would be about 12 milliliters. 20 grams, 40 mils, here would be my reasoning, 40 milliliters of B has a mass of 20 grams. I would need 12 milliliters of A to have that same mass of 20 grams. So 12 milliliters. Water has a density of 1. How would you sketch the line? You'd simply go up here, find where 10 meets 10, and 20 meets 20, and 30 meets 30, and 40 meets 40, because those would all have that same slope, and I'm just going to put this here and label it as water. Okay, now, what would happen if you put some A into this water, or B? Some people are going to look and say, A line's higher, so it floats. But this isn't a representation of what floats or sinks. I need to look at their densities. A has a density of 1.6 grams per milliliter. It's greater than 1. A would sink. Its density, defend your answer using the mass volume graph, its density is greater. It would push the water out of the way. B only has a density of 0.5 grams per milliliter. It's less than 1, so it will float. And so defend it. B, the substance of B has a volume based, we just figured out its densities, has a density less than 1, it would sink. I'm sorry, it would float.